Hi, ladies and gentlemen. This is Mr. Green. This is another in my series of lessons on statistics. We're going to be looking at probabilities this week, or this time. So let's think about probabilities in the terms of dice. Let's toss a single-sided dice, and what are the possible answers when you throw a dice and it's going to roll on the ground? You're going to get numbers. You're going to either get a 1, a 2, a 3, a 4, a 5, or a 6. So the question is, what's the probability, P, of getting a 5? What's the probability of getting a 5? Well, it's a 1 out of 6 probability because there are 6 possible combinations and you might get one of them. Okay? So it's the n of the of that particular event and the n of that particular space that you're looking at. The possible number of volumes there. I'm sorry, the possible number of values there. So what's the probability of at least a 4? Well, if it's at least a 4, that means it's either a 4, a 5, or a 6. So that means there's 3 of those that it could be out of the total 6, or a 1/2 50-50 probability. What's the probability of it being a prime number? Well, our prime numbers in this situation are 1, 2, 3, and 5. 4 is not prime and 6 is not prime. So we've got 4 possibilities there. So it's a 4 out of 6 probability, or a 2/3 probability. Okay? So let's look at 2 dice. What happens when we roll 2 dice? Well, we know that we could get a 1 on any one of them, or a 6 on either one of them. 1 through 6 on either one of the 2 dice. And we're looking at the sum. So let's sum these up. That'd be a 2, that'd be a 3, that'd be a 4, that'd be a 5, 6, and a 7. That'd be a 3, that'd be a 4, that'd be a 5, that'd be a 6, that'd be a 7, that'd be an 8. That'd be a 4, 5, 6, 7, 8, 9. You see what I'm getting here? I'm just filling in the table, aren't I? With the sums of the 2 dice. 5 and 3 would be 8. 6 and 5 would be 11. 6 and 6 would be 12. Right? Go ahead and fill these all out real quickly without talking, because I can do them quicker that way than I can if I'm talking. Okay, so I got them all filled out. So they're asking me, what is the probability of the sum being 6? Well, let's look at this. Where is my sum 6? It's 6 there, it's 6 there, it's 6 there, it's 6 there, it's 6 there. How many of them did I highlight with that 6? I highlighted 1, 2, 3, 4. I highlighted 5 of them. How many were there total? Well, 6 by 6, there's 36 of them. 36 possible values there. So the probability of the sum being 6 is actually 5 out of 36, which is what I said there. Let's look at another one here. Find the product is 30. The probability of the product being 30. Well, that means filling out the table to get the product, and so I'm going to just go over here and do that. It's already been done for me, and I can see there's 2 of them that have 30, so that's a 2 out of the 36, or 1 out of 18. Okay? So what I'm doing here is I'm finding the sample space, aren't I? That's what this is over here. This is the sample space. And then I'm highlighting in the sample space the ones that satisfy the condition. So that's what you have to do to find these probabilities. So what is the probability that you could guess a random person's birthday correctly? Well, think about it for just a second. You're going, oh my gosh, I don't know if I could do that. How many birthdays do they actually have? Just one. That's all they've got. And the question is, how many possible days could they have a birthday on? Well, there's 365 days in a year, so the probability would be 1 out of 365. Interesting? That's how probabilities work. Okay? Now, we're going to continue on through this course, and our next one is going to be looking at independent and dependent, or independent nature of different possibilities. And we'll look at that next time. So, I'll look forward to seeing you. Bye.